Welcome to Chapter 17, Section 1. This is Part B on calculations. So in this section, we're going to practice solving problems involving electrical energy and potential energy. So we need to pause here and remember our two equations that we just learned. So we have the first equation, which is potential energy. This is our electric potential energy, equals a negative QE D. And then we need to remember our second equation for our potential difference. So that's delta V equals negative ED. So then looking at our first example equation, let's go ahead and read this. And it says a particle moves 10 meters along an electric field of strength 75 newtons per kilometer. And its electrical potential energy decreases by 4.8 times 10 to the negative 16th joules. What is the particle's charge? So if we're pausing here and remembering the way that we solve problems, we want to look for what it's asking us to find first. So at the end here it says, what is the particle's charge? And so we're going to need to remember that charge is Q. So that's what it's going to be asking us to find. Okay. And then I just want to think and visualize what's happening in this so that we can understand everything. Okay. So we have a uniform electric field, because remember everything we talk about is now going to be this uniform electric field, where E equals 75 newtons per coulomb. Okay, so what we have then is we have some little particle, okay, is traveling along, and it's going to move down this field, okay, 10 meters, which is a pretty long way, okay, and I know it goes down the field in the direction of the arrow because it says the potential energy decreases. So that means our potential energy here is going to be a negative 4.8 times 10 to the negative 16th joules, okay? So this must be a positive charge that's traveling down this line, okay? So hopefully our answer when we're done ends up giving us a Q that's positive, okay? So I think that's all the information we need to pick out. We identified that we want Q, we know PE, and we know E. So that is all of our information along with the distance here. So I've put together here on this next slide written out nicely so that now we can plug things in and solve the equation. So if we take this right here and we're just going to write it up here again, we've got PE equals negative QED. And plugging in my information to solve it now, I know that PE is negative 4.8 times 10 to the negative 16th joules. And that's going to equal negative Q, because that's what I'm solving for. E is 75 newtons per coulomb, and our distance is 10 meters. So if I rearrange this and solve for Q, I'm going to get Q equals negative 4.8 times 10 to the negative 16th joules divided by negative 75 newtons per coulomb times 10 meters. And when I plug that in, I end up with Q being a positive 6.4 times 10 to the negative 19th. And it's this, if we look through all of this, it will cancel out to be just, coulombs here, because charge is measured in coulombs. So this is our final answer, and you notice these two negatives here, they did indeed cancel out and give us a positive value for Q. So that helps us know that we did the problem correctly. We're going to look at one more problem now. So in this one asks us, what is the potential difference between the initial and final locations of the particle in the previous example? So we need to think about the information that we already have in the equation. So it's asking for potential difference. So that's our delta V equals negative ED equation. And from the previous page, we know that E is 75 newtons per coulomb, and we know that D is 10 meters. So we can simply just plug those into our equation to find the potential difference. We're going to get a negative 75 newtons per coulomb times 10 meters. Don't even need a calculator for this one because it's going to give us negative 750 volts is our potential difference. Okay, this negative just indicates the direction of the potential difference, so don't worry too much if you get a negative answer. Negative just indicates direction. All right, so there's a couple examples for the math in this section. I'll see you guys in class.